The sun is going to explode. Not today, not tomorrow, but it's going to happen. The sun has a timer on it, and when that timer runs out, our star dies violently. Now, you might think this is some distant abstract thing, something so far in the future it doesn't matter. And you're right about the timing. We've got about 5 billion years. That's a long time. Longer than life has existed on Earth. Longer than the Earth itself has existed in its current form. But here's what you need to understand. The process is inevitable. It's not a question of if, it's a question of when. And the physics that will kill the sun, that same physics is playing out right now in stars all over the universe. We can see it happening. We can measure it. We can predict exactly what's going to happen to our sun because we've watched it happen to thousands of other stars. So let me tell you the story, from beginning to end, what the sun is doing right now, what's going to change, and what happens when it finally dies. The sun is burning. That's what you've been told your whole life. The sun is on fire, burning bright, giving us heat and light. Wrong. The sun is not burning. There's no fire. Fire is a chemical reaction, carbon and oxygen combining, releasing energy. That's what happens in a campfire or a candle. But the sun isn't made of wood or wax. The sun is made of hydrogen and helium, gases, and those gases aren't burning. What's happening in the sun is nuclear fusion. Hydrogen atoms are being crushed together under enormous pressure and temperature, fusing into helium atoms. And when they fuse, they release energy, huge amounts of energy. That's what makes the sun shine. Every second, the sun converts 600 million tons of hydrogen into helium. And in that process, about 4 million tons of mass gets converted into pure energy. E equals mc squared. That missing mass becomes light, heat, radiation. That's what you feel on your face when you stand in sunlight. Energy from fusion reactions happening 93 million miles away. Now, here's the key thing to understand. The sun is in balance. Gravity is trying to crush the sun inward. All that mass, 2 trillion kilograms, pulling itself together. That should collapse the sun into a tiny ball, but it doesn't. Why? Because the fusion reactions in the core are producing so much energy, so much outward pressure, that they're holding the sun up against its own gravity. It's a constant battle. Gravity pushing in, fusion pressure pushing out, and right now they're balanced, perfectly balanced. This balance has been holding for 4.6 billion years, and it'll hold for another 5 billion. But then something changes. The sun runs out of hydrogen. Not all of it, just the hydrogen in the core, the center of the sun where the temperature and pressure are high enough for fusion to happen. See, fusion only happens under extreme conditions. You need temperatures around 15 million degrees Celsius. You need densities thousands of times higher than lead. Those conditions only exist at the very center of the sun. So the core is fusing hydrogen into helium. But eventually, all that hydrogen gets used up. The core becomes pure helium, and helium doesn't fuse, not at these temperatures. Helium fusion requires even higher temperatures, around 100 million degrees. The sun's core isn't hot enough yet, so the fusion stops. And when the fusion stops, the outward pressure disappears. Suddenly, there's nothing holding the core up against gravity, and gravity wins. The core collapses. It shrinks, gets denser, gets hotter, and as it collapses, it releases gravitational energy. That energy heats up the surrounding layers of the sun, the layers that still have hydrogen, and those layers start fusing faster than before, producing more energy than the sun has ever produced. This is where things get strange. The core is collapsing, but the outer layers are expanding, massively expanding. The sun swells up, gets bigger and bigger. The surface moves outward, and as it moves outward, it cools down. Hot things that expand get cooler. That's thermodynamics. So the sun gets bigger and cooler. It turns from yellow to orange to red. It becomes a red giant. How big? Huge. The sun will expand to about 100 times its current size, maybe more. Its surface will reach out past the orbit of Mercury. past Venus, maybe even past Earth. Think about that. The sun's surface will be where Earth is now. If Earth is still here, and that's a big if, it'll be skimming through the outer atmosphere of the sun. The temperatures will be thousands of degrees. The oceans will boil away. The atmosphere will be stripped off. The surface will melt into a sea of lava. Earth becomes uninhabitable long before the sun actually reaches it, probably 1 billion years before. But let's focus on the sun. The core is still collapsing, still getting hotter and denser, and eventually it gets hot enough. 100 million degrees. That's the threshold. That's the temperature where helium fusion can start. And when helium fusion starts, it doesn't start gently. Helium ignites all at once. The entire core, all that compressed helium, starts fusing simultaneously in what's called a helium flash. It's an explosion, a massive release of energy. But it happens deep inside the sun. The outer layers contain it. They absorb the energy. The sun doesn't blow apart, but it shakes. The outer layers pulsate. Material gets thrown off into space. After the helium flash, the sun stabilizes again. Now it's fusing helium in the core, producing carbon and oxygen, and it's fusing hydrogen in a shell around the core. 2 fusion zones. The sun shrinks a bit, settles down. This is a calmer phase, but it doesn't last long, maybe 100 million years, a fraction of the sun's total lifetime. Eventually, the helium in the core runs out. Same problem as before. Fusion stops in the core. The core collapses again, heats up again. The outer layers expand again. The sun becomes a red giant for the second time, even bigger this time. The surface might reach past Mars, and here's where the sun's fate is sealed. The core is now made of carbon and oxygen. To fuse carbon, you need temperatures around 600 million degrees. To fuse oxygen, you need over 1 billion degrees. The sun is not massive enough to reach those temperatures. The core will never get hot enough. The sun doesn't have enough mass. To fuse heavier elements, you need more gravitational pressure. Bigger stars, stars with more mass, can squeeze their cores harder, reach higher temperatures. Those stars can fuse carbon, oxygen, neon, silicon, all the way up to iron. But the sun isn't big enough. It's stuck. So the core just sits there, a ball of carbon and oxygen, dead. No fusion. It's called a white dwarf. Incredibly dense. A teaspoon of white dwarf material weighs tons, but it's not producing energy anymore. It's just sitting there, slowly cooling down over trillions of years. Meanwhile, the outer layers of the sun, the red giant envelope, are unstable. They're pulsating, expanding and contracting. And with each pulse, some material gets thrown off into space. The sun is shedding mass. Slowly, over thousands of years, the outer layers drift away. They form a glowing shell of gas around the core. We call this a planetary nebula, not because it has anything to do with planets, but because when astronomers first saw them through telescopes, they looked like the disks of planets. So the sun ends as a white dwarf surrounded by a beautiful glowing nebula. The nebula fades over tens of thousands of years. The light dims. The gas disperses into space, and all that's left is the white dwarf, a dead stellar core no bigger than Earth, shining only from leftover heat. Slowly, over billions and trillions of years, it cools. It gets dimmer and dimmer. Eventually, it becomes a black dwarf, a cold, dark lump of carbon and oxygen floating through space. That's the sun's fate. That's how it dies. But let's talk about what this means for us, for Earth, for life. Long before the sun becomes a red giant, life on Earth ends. Why? Because the sun is getting brighter. Right now, the sun is about 30% brighter than it was when it first formed, and it's still getting brighter, slowly but steadily. About 1% brighter every 100 million years. That doesn't sound like much, but it adds up. In about 1 billion years, maybe a bit more, the sun will be bright enough that the Earth's oceans start evaporating. Water vapor is a greenhouse gas. More water vapor in the atmosphere means more heat gets trapped. The planet heats up more water evaporates. It's a runaway feedback loop. The oceans boil away. The atmosphere becomes thick with steam. Surface temperatures rise to hundreds of degrees. Earth becomes like Venus, a hellish, lifeless hothouse. This happens long before the sun swells into a red giant. So humanity, if we're still around, has maybe 1 billion years to figure out how to leave. Find another planet, another star system, or build habitats in space, or something, because staying on Earth isn't an option. And when the sun becomes a red giant, if Earth hasn't already been consumed, it will be then. The sun's outer layers will engulf the inner planets. Mercury definitely, Venus definitely, Earth maybe. Depends on exactly how big the sun gets, and by that point, it doesn't matter. Earth is already a charred, lifeless rock. The sun finishing it off is just the final act. Now, you might be thinking, why should I care? This is 5 billion years away. Humanity might not even exist then. True. But here's why it matters. This process, the life and death of stars, this is how we got here. The sun is a second or third generation star. It formed from a cloud of gas that included elements heavier than hydrogen and helium, carbon, oxygen, nitrogen, iron, all the stuff that makes up Earth and your body. Where did that come from? From stars that died before the sun was born. Big stars that fused hydrogen into helium, helium into carbon, carbon into oxygen, all the way up the periodic table. And then those stars exploded as supernovae, scattering those elements into space. And some of that material ended up in the cloud that formed the sun and the solar system. You are made of star stuff. Carl Sagan said that, but it's true. Every atom in your body except the hydrogen was forged in the core of a star that died billions of years ago. The calcium in your bones, the iron in your blood, the carbon in your cells, all of it came from stars. And when the sun dies, it'll return some of that material to space. The planetary nebula will spread out. Over millions of years, it'll mix with other gas clouds, and eventually, some of that gas will collapse and form new stars. Maybe some of those stars will have planets. Maybe some of those planets will have life. Life made from atoms that once belonged to the sun. That's the cycle. Stars are born, they live, they die, and they make new stars. It's been happening for billions of years. It'll keep happening for trillions more. So when the sun explodes, well, it doesn't exactly explode. It sheds its outer layers gently. But when the sun dies, it's not an ending. It's a transformation. The atoms that make up the sun will go on to make new things. New stars, new planets, maybe new life. The sun will die. That's certain. The physics is clear. But the matter and energy don't disappear. They just change form, and that's the beauty of it. Nothing is permanent. Everything is process. Everything is transformation. Stars die so that new stars can be born, and we get to witness it. We get to understand it. We get to predict with precision exactly what will happen to our sun billions of years from now. That understanding, that ability to look at a ball of hot gas 93 million miles away and know its entire future, that's one of the greatest achievements of human intelligence. The sun will die. We won't be here to see it, but we know what happens next. We know how the story ends. And that knowledge, that certainty, that's beautiful, not sad, not frightening, beautiful, because it means we understand. We figured it out. A species of apes on a small planet looked up at their star and calculated its death. That's extraordinary. That's what science gives us. Not comfort, not immortality. Truth. The sun will die. And now you know exactly how.